This is number 38 in section 4.4, and here we're going to solve a boundary value problem, meaning we have a differential equation and two boundary conditions, or two conditions for the solution to satisfy. Okay, so the first thing we do, once again, is we use what we learned in section 4.3 in order to find the general solution for the homogeneous part of the equation. And so this is what I've found right here after getting the auxiliary equation. So, and then the next thing is to find yp, or the particular solution. So I'll go ahead and do that. Yp, I'm going to go ahead and make a guess that is linear. Reason being that here we have 2x minus 2, which is linear. So our guess is that our solution yp will also be linear. I noticed that there's no linear equation that is a part of my homogeneous solution, so I can just use the linear, exactly ax plus b. Now the next thing that I need to do is take yp prime and yp double prime in order that I can check that yp satisfies the initial differential equation. Now to do that, I put in yp double prime, which is 0 minus 2 times yp prime plus 2 times yp, which is ax plus b. And that needs to be equal to 2x minus 2. So now by solving this equation, hopefully we'll find out what a and b are. So let's see, I'm going to take all the coefficients of x, and that's 2a times x, and then all the constants. So that's 2b minus 2a. Those are the constants. And that has to be 2x minus 2. So the coefficients of x must be equal, so 2a must be equal to 2, or a is 1. And the constant must be equal on both sides. So I get 2b minus 2a equals minus 2. So that b minus a is equal to minus 1. Let's go on further. Or b is equal to minus 1 plus a, which is minus 1 plus 1, or 0. So b is 0, a is 1, and that gives us then, let me go up just a little bit, so we see here's the homogeneous solution, and yp is going to be just x, and the general solution is going to be e to the x c1 cosine x plus c2 sine x, so yc plus yp, which is x. Now we're going to use these boundary conditions to find what c1 and c2 are. So let me write them down again. If you notice, they were up here, so I just want them to show in the same frame. And so let's apply y of 0. We get e to the 0, which is 1, times c1 times cosine of 0, which is 1, plus c2 times sine of 0, which is 0, plus 0. And so I have here, really I just have c1, and this needs to be 0 according to this condition. So c1 is 0. Y of pi, I have e to the pi c1 times the cosine of pi, which is negative 1, plus c2 times the sine of pi, which is also 0, plus pi. Now this is e to the pi times c1 plus pi, but c1 has to be 0, so this is just pi. And sure enough, that satisfies the condition. Doesn't really determine what c2 should be or anything. So c2 then is arbitrary. And finally our solution is e to the x times c2 sine x plus x. And this holds for any constant. C2.